All right. All right. Hey, good morning, everybody. I wanted to welcome everybody to Ocean State's, as you can see, first attempt at online training. In the event of the COVID virus, we figured we'd try to take advantage of this downtime and try to get a little bit of training. This is basically the Siemens M60 controller programming training that we were going to do in our new training room that we're in right now, but because we all can't get together, we figured we'd give it a shot this way. Basically, everybody, I think we have about 30 people online right now, so that's awesome. What we're going to end up doing is we're going to mute everybody so there's no feedback, because that's what we were getting in the beginning. And then there's,
what is it? People know that there's a chat if they have a question. And two, if they're hearing through their audio, they can disconnect from their phone.
All right, there should be 3 little dots. You guys should have a little chat box to the right hand of your screen. If you want to type in questions at any time, go ahead and type them in. And I'm in here with Mike and Wayne, and they're going to feed the question to me because I can't see it on my screen. But type the questions in at any time during the discussion, and we'll get those answered for you. Is that it?
Yeah, and now if they can hear the audio through the computer, they can hang up their phone.
All right, and if you can hear the audio through your computer, then you can hang up the phone. You don't need audio on your computer and audio on the phone. It was basically one or the other. The default for most people is going to be mic and speakers through your laptop or your PC. In the event you didn't have that, then you would use the phone and basically just listen in that way. So don't do both, only do one or the other. We appreciate everybody's patience. I'm sure we're going to learn about how we're doing this. So as the weeks come, we can kind of fine tune this on our end. So I think we have everything. I think we have everything we need to know there. Again, if you have any questions, just type them in. As you can see behind me, basically I'm going to have 2 screens that I'm going to be working with. So that's a board that I drew out, and I'm going to go over the phasing structures, ring structure, and the diagram in a little bit. And I'm going to be toggling back and forth between a telnet session that I have with an M60 controller. So I threw out in the email, if anybody had a controller, they could use it at home, so you could basically follow along. If we were doing this training in a class, it would basically be 2 guys to a controller, and you could follow right along. But we don't have, obviously we can't do that. So the controller is just a benefit for you guys. If you don't have one, don't worry about it. You'll be fine. What I wanted to do is basically, we get a lot of questions all the time about programming on the M60. It's a little bit different. It's a little bit broken out more. We feel though it's a little easier to follow compared to older revisions. So that's why we wanted to do this training. Basically, this is a programming. I'm going to get into some explanation of some of the features, but like, for example, like when we get into coordination, it's not going to be a coordination class per se. It's more of an explanation on how to program the coordination in. There will be some explanation of coordination so you understand what it is, but it's not a full-blown coordination class. I don't know if we can do that online. That might be more of an in-person thing, but we'll gauge it as it goes. I'm probably going to break this out into 4 different weeks. So that way the classes only run between like an hour and an hour and a half. That way, you know, you can take in just enough information that you need to know, and then we move on. We are recording this. Our hopes is that it's going to come out just like you're seeing it now. Once it gets recorded, we're going to look at it afterwards, and then we're going to put it on our website. If you notice down here on the bottom of the screen, for those that have never been to it, I got my handy little orange pointer here. So here's the website, www.oceanstatesignal.com. We're actually redoing it again, and we're going to have a section that's going to have all our presentations on it that you can go back to. So hopefully if this works out well, I'll shoot you guys all an email and say, hey, if you missed it or somebody didn't get to see it, you can go look at it on the website. All right. Hold on, let me just mute my phone. Okay. All right, so first thing we're going to go through is I'm going to cover all the basic stuff that's in the controller. If I'm skipping over a section, it's just because nobody ever uses it, and I want to focus on the program that you guys always use. So that way you'll retain that. I don't want you to get caught up into something that basically that you very rarely use. All right. So for those of you not familiar with, and again, basically all the people, just so you know who the audience is the majority of the people is all municipal people. There's probably about 30 something people on it. It's all municipal electricians and technicians. We get a couple of city engineers on here. And then I invited in the Mass DOT electricians. They asked if they could join in, and I think there's a couple of contractors on. So you guys are kind of all in the same group. Some people a little more advanced than others. But again, this is starting with the basics. So it could be review for some of you, but for the rest, it's going to be learning, and everybody tends to pick up something along the way. Typically, just a little history, should it doesn't begin in Gary Macro and Ocean State Signal. I'm in here with Mike Wesolowski. He's walking around. Mike came to us a couple years ago. And Wayne Owen, we picked up last year. He's our IT guy. Basically, Siemens controllers, what you guys are all basically used to seeing are MO3s, M10s, M40s, M50s, and now the M60s. We had a little bit of hiccup with the M60s. We had a little bit issue with power supplies. I think we've kind of got through that a little bit. On a side note, if anybody has any issues, make sure you call me. We'll get that taken care of for you. So one of the nice things that we came through at the M60 is you'll look at here's what we call our main menu screen. You'll notice we have two screens in one. So it's a 16-line display. There's 8 lines up on the top, 8 lines at the bottom. And it gives you the ability to program on the top where you're actually watching active status below. That's a huge benefit to our older controllers where you always had to kind of toggle back and forth between programming and watching. Some of the older controllers have a black and white display. All the newer ones have a color display. That's been helpful. They've kind of enhanced that a little bit so you don't get too much of the sun glare on there. So basically you'll notice on the front screen up on the top, CPAC, you'll see the number 3.5AD. That's the software revision. That's 3.5AD is what we've been using quite a bit, probably over the last couple of years. Anything 3.5.5 and older are pretty good versions of software that you shouldn't have problems with. That's the majority of stuff that's out there. If you have controllers that are 3.5.6 or 3.5.7 and they're working and they're operating a little inconsistent, you may have issues, you don't really understand what's going on, you can always bring those to us and we can upgrade. Those were short versions that Siemens, when we started introducing flashing yellow arrow was the key component. Unfortunately what happens is they make a change and then sometimes they break other stuff. So just why I got everybody out here, 3.5.6, 3.5.7, most of them are going to work fine for you, but if you do have a hiccup, I know one thing in 3.5.7, if you're using overlap C, you could have a problem with that. That's something that we want to get upgraded. We didn't really have that many out there. I think they went out for like 6 months and we went right to 3.5.8. 3.5.8, B and C work fine. D is the most steady platform. So if you have those, don't worry about it too much. The date to the side, March 2018, that's basically just when it comes out. Don't get too tied up in that date. And then the biggest thing in the middle is where it says Linux. So M60s have gone to a Linux operating system. Basically, the older controllers were on what they call OS 9, and it was basically maxed out as capability with the older controllers. So as we wanted to start adding new features, we had to go to a new platform. All the manufacturers now have Linux-based controllers. A lot of the specs come out and ask for a Linux-based controller. So now we're probably using 50 to 60% of its capability. So that allows us 40% of growth for manufacturers to add new technology and advancements. And then you'll see basically the main menu status, active status, utilities, phase data, unit data, core data, time-based data, preempt, priority system, and reports. And we're going to start going through these. Again, like I said, I want to break this into about a 4-week training. And today we're going to try to get through utilities, phase data, and unit data. So we'll see how that goes. And then probably do core data and time-based together. And then we'll do preemption and system together. And then the last one will go into active status, and we'll go through alarms and kind of things to look for troubleshooting wise. So we'll save that one to the end after you kind of learn what all the terms are and everything. I sent a glossary out to most people in a first email. Hopefully you guys went through that just to kind of familiarize some of the terms that I'm going to be using, so you understand, you know, how it all comes together. If you didn't get that, shoot me an email and I can send it to you. I'll probably put that on the website as well, so you can get it off of there. Again, if you have any questions, type them in the chat, and Wayne will let me know. So again, we're going to skip active status because we're going to save that till the end, and we'll go right into utilities. So there's a couple things here in utilities. One thing that you guys run into, if you default a controller, a lot of times it'll come back and you go to change some programming, and it'll ask you for the access code. So basically it'll come up and it'll say, you go to change something and it'll say access code not active. So one thing you would go to, let me go F, right? So you would go into enable access. So I don't have to do anything right here because I've already gone through this process. But if you did, and you can jot this down, I hope you guys are taking notes, you would want to enter 4 zeros. So 4 zeros is the default code that allows you, after a default, to now start making programming changes. So you just go 000, enter. And then the one thing that I would do is go to change access, and you can type in 4 nines and enter. And you'll notice it says perpetual access. So that means it's omitting all the code, all the access codes, and you should never have that problem again unless you have to default it. Some districts like to put in a security code. We're not opposed to security codes, but if you put a security code, we ask you to document it. And maybe, you know, you don't really want to document it in the cabinet, because if somebody gets in the cabinet, they can get in there, but it has to be somewhere where you know where it is. And then obviously, if we're going to go out there or you're going to go out there, we need to know what those codes are. So they're not a bad thing to have. One of the things that, you know, we talk about is we're starting to finally develop a lot more traffic networks for folks in their municipality, is security on the network. We'll get into that a little bit later. So it doesn't hurt to have some security in the controllers. But basically, whatever I've been doing this 20-something years, there's one code that I typically always know about, and that's Christmas. And that's in one part of Massachusetts. Other than that, I've never really ran into a code before. So in the event you put a code in and you forget that code, there is no backdoor to get to the code. The only way for us to get to it is we have to go in through tactics. So we go in through the tactics is the Siemens management software. If we go into tactics, then it'll show us the code and we can make the change there. So don't get too caught up in the code. I just wanted to explain what that is.
Put out a caveat right now that apparently the chat's not working because they're all guests. So I'm looking at fixing it.
All right. So right now, because you're in regards to the training, the webinar, you're all in as guests. So I guess you can't enter questions for those trying to enter questions. We're trying to work through that right now. So just kind of bear with us. If you have a question, write it down. Once we get this going, we'll come back and answer them. Back to that. All right. Here's something that I always recommend to people to do, especially all maintenance people. You guys have spare controllers. You get a new controller out of the box. The first thing that I always recommend you to do is default the controller. If you're using anything in a TS1 setting, which I'll get into, TS1, TS2, in a TS1 setting, the key thing is the default resets the ring structure and the signal output drivers. And that's where we want to start at. Because at that point, we basically just need to turn a few phases on and off and we can get the intersection running. So to set it to default, basically you just go to 4 and then 1 for low defaults. And you'll see the green square where it says full function CPAC current mode. And then to the lower left, lower right, it'll say E low default. All you do is hit the E. I'm not going to default this one now. Actually, I could, I'm not gonna, no, because it's gonna take out my comma over there. So you could default it right now and basically set this thing back to normal. Then it'll be, so when you call me and you say, Gary, hey, I'm trying to get this controller program, it's doing something quirky, and we start going through the menu structures, and you're telling me where there's data in certain places that isn't making sense, I'm gonna say, you know what, I don't know what we're working with, let's go back and default the controller, because then I know where I am without you having to go to all the different menus. So it's easier for me, it's easier for you, and that way because if a controller, for some reason you did a download from Tactics and it didn't take all the information, that can prevent it from running. And it can be a piece of data that you don't even go to that screen to look for. You don't need it. But if that piece of data didn't get populated, the controller may not run. Once we default it, now we're back to a clean slate. So that's default. The other thing is, in the M50s, some of you use this, we had something called a data key. So basically, on the left-hand side, there was like a little slot, and it actually had a little plastic key that would go in there. We could save data, we could save our INT files onto that key, and we could transfer that. The key thing wasn't bad, but now we've kind of stepped up, and now we have a USB slot that's a USB port on the side of the controller. So essentially, we can use that USB for two things. We can save the INT files. If I go in, so basically they'll say load configuration data from USB or save configuration data to USB. So that's been pretty good. Keep in mind, that works on 358 only. If you try to use it in older ones, it doesn't really work that well. So that's a 358. The next platform that comes out, you'll probably start seeing next year, is going to be our Siemens 5.0. Some of you have seen it a little bit already, but 5.0, I'm going to do this class probably again next year on 5.0, and I'll be able to update you on features that are now readily used. But right now, INT files are 358 only. I wouldn't recommend trying to do them with other versions. So don't take a 358 and try to stick it into a 356, you're just going to totally screw up that whole controller. So don't do that. So basically, that's just loading and saving from the USB key and doing the defaults. There's a diagnostic screen. Again, you don't have to worry about that. Configure ports. This is a key screen because this is when you do communication to the controller. If you're doing a serial connection to the RS-232 port 2, this is where you're going to come in and you're going to set the baud rate. So based on what your laptop is set to, typically we upload and download it 9600. So you'll see the little chart that says 1200, 4800, 2496, etc. We would set that to a 4. And basically the board, because whatever the baud rate is set in your laptop is what the controller needs to be set for. We're going to do a communications class down the road, but just to kind of give you an example. So whatever it's set to, that has to match there. Older controllers, M03s, M10s, didn't have this option. They all communicated at 1200. So you had to change your laptop down to 1200, which you can still communicate now. All that is the speed. How fast do you want to upload and download the data? The way we do it a lot now is actually over IP. So that'll be the next class. We're going to get you guys doing it over IP because now the downloads literally take seconds. Which brings us to the next thing is if you go to 4 for IP address, and this is something that you guys need to start becoming cognizant of, and we're going to start doing a lot of trainings drilling this in your head. You guys change a controller out, especially at the state level for the state guys over here. So anybody that has adaptive control systems, all these controllers in there all have IP addresses in there. So if that controller goes down and you take it out, you have to put all this networking information back in there. Otherwise, that controller will not go back online and it won't work in your adaptive solution. So you guys have to start learning, and we're going to teach you this. We're going to keep drilling it in your head Think of it in the old closed loop systems. You went to location 3, you made it address 3, and it talked to the master. Now, instead of address 3, we got to put in IP address 192.168.1.102, because that's how I'm communicating right here. Subnet mask and broadcast, we'll get into all that. If you can get the IP address in there, that's a huge part of it. What I want you guys to get out of all these classes is when a controller goes out on the street and we program it for everything for the design plans, signal, timing and sequence, coordination, time-based preemption. Unfortunately, when the controller goes down, the replacement one gets the timing and sequence and doesn't get everything else put in it. Fire department complains that preemption doesn't work. City engineer complains because now the coordination doesn't work at that intersection anymore. So with these classes, I want you guys to get familiar on taking the information out and putting it all back into the controller. I understand it happens at 2 in the morning, 3 in the morning, when it's raining and the weather is bad, but we're trying to get you guys trained to not do 80% of it, but do 100% of it. Those that use laptops, those that use tactics, you can save all this information, and it's super helpful. I'm just getting a few people. Can you just check to see if anybody else is trying to get in the meeting, Wayne? Jim from Hamden said he's trying to get in.
There's no one in the
No in the waiting room? Okay. So again, those that use laptops, you can pretty much upload everything and download it, but we have to know how to do this by hand. You got to know how to do it both ways. And while you're doing it, make sure you get everything put in. Take the extra 10 minutes and make sure all the information gets in there. So again, IP addresses go in here. And then, sorry about that. 6. And then the last thing that you would have to put in is something called a gateway that basically looks something like your IP address. So I forget what mine is. This is one that we've just been working on in Nashville. So that's part of the whole network structure that allows the communication back and forth from the central computer that'll keep these things online. So basically those two components. How's our question Q&A thing going? Is that working yet?
It said they had access.
Okay.
I just don't know why.
All right. UTCS configuration. This is something you'll never use. Basically, UTCS. You'll always hear, if you've been through a bunch of my classes, I always refer to Boston. Boston controllers run off a central computer or a UTCS computer. Basically, that computer makes all the commands that control the intersections. That's where we would start using some of the Boston protocol. Scoop is one of Siemens adaptive signal systems. We don't have any in New England. We tried to get them in. They're a good system. They're a little pricey. They use them in other parts of the country. We don't use them around here, so you don't have to worry about it. Sorry. And then the only other important one would be GPS configuration. Here's something else too. A lot of controllers go out with GPS configuration. So what this is, move my screen over a little bit. Sorry. Is a GPS sync, all it does is sync your time clock. So when we do any type of coordination, if there's conduits that are running fiber, wireless, copper in between intersections, a lot of times they'll want to add one more intersection in and they don't have the conduit going there. So they don't want to spend the money to put the conduit in, it's costly. So they'll just put a GPS device on the cabinet. Most of you have all seen them all. It's a little black hockey puck, goes on top of the cabinet. A cable comes down, it plugs into port 2 on the controller. And basically that just keeps the satellite time. Because all of our controllers, everybody's controllers, the clocks drift over time. It's seconds over a day, it's minutes over a month. So by the end of the year, you're hours off. When we do the coordination, and I'll talk about this, it's critical that we have the accurate time sync through the whole corridor. So when we do something called an offset, the seconds line up at each intersection. and that's what does our progression down through the arterial. So by having a GPS out there, that keeps the time sync. We've done arterials where we've just done GPS in 4 intersections, and we've done the coordination that way. It works fine. You know, it's a cheap and dirty way of doing communication. There's no communication from controller to controller. It's just communication to the satellite to keep the time sync. In this screen right here, basically where it says that where the green key is, basically all I would do is turn on the 1 for GPS. And then there's another screen, the time clock, where I'll show you the rest of the GPS coordination. But for right now, that's one parameter. So if you go again, if you change out a controller and you notice it has one of those black antennas on top, that's GPS. We got to put that information back into the new controller. All right. And one other thing you hear a lot is SPAT addressing. SPAT addressing, that stands for signal phase and timing, right? So basically what they do is, again, so you'll see destination IP. A lot of what we do now is based on IPs, the port and the enable. So SPAT data, you'll hear a lot of the term, they're doing something called a SPAT challenge. There's a big project out. Mass DOT is doing it on Route 9, Framingham, Natick, all through there. It's like 30-something intersections. They do the SPAT challenge. It's another form of, it has a little bit of adaptive component in there. They basically want to see how well the intersection is performing. And what we do is we take that SPAT data out of the controller to kind of see how well everything is operating. They go back, the engineers analyze it, they make adjustments, and that's basically, in a nutshell, how the whole thing works. So that's just another piece of the information of the puzzle of more stuff that we can get out of. Hence, Linux-based controllers that was difficult to get out of. Well, we really couldn't do it in the older OS 9s, so we had to get it out of the a Linux-based controller. Again, stuff that you don't need to worry about, and that's probably the only guys would be the state guys would kind of get involved in that at this point. But eventually, we do work at some municipalities at city level. I know Quincy, if they're on here, Milton, they'll be getting involved in this. Framingham a little bit will be getting involved in this. Westfield. So, you know, as we're trying to push this out into the municipal world, because this is all beneficial information that's out there. All right. So that kind of sums up the utility screen. Not that exciting. The main things you want to get out of the utility screen is access data, loading defaults, and setting baud rates and IPs. Those are the 4 keys that you're going to get out of it. Questions? Good?
I logged in as a guest.
Yep.
I have a home computer, and I'm able to type in.
Okay, all right. So the question thing is working. If you guys have questions, send them in.
They have to click the chat box first to the right of the 3 buttons, or the chat's not there.
Okay, so if you don't, on your little toolbar on your screen, if you scroll in the middle, if it's not up there already, you'll see a little toolbar. To the right, it'll say chat. If you click on that, you'll get a little window pane open on the right. And down the bottom, it'll have a little space bar that you can type in questions. So in case you don't know where it is, that's where it is over there. All right, now we're going to get into the fun stuff. So everybody pay attention. All right, phase data. All right, before I get into phase data, I'm going to go over the chart behind me because a lot of you guys have seen it and haven't seen it before. Somebody's telling me only team members can chat.
Cranston said, hey there.
Okay.
Everybody's a guest.
All right. All right. So behind me, a lot of you guys have seen this before. I'm going to go over it because this is going to make sense to a lot of what I'm going to cover in the phase data and the unit data. Okay? Hold on.
Cranston said, hey. Kevin from Westfield said, hey.
All right. So Chris in Fall River, there's other people that are typing in to ask questions. So make sure you're enabled to chat. If you can enable the chat, you should be able to ask a question. All right, so here we go. So starting at the top. You'll appreciate it since we didn't get any snow this year. I took a little snow thing for my driveway, and that's gonna be my pointer for the day, so you guys appreciate that. All right, so up here on the board, basically some of the terms that you're gonna hear me use, phase, ring structure, barrier, ring. All right, those were in the glossary of terms that I sent to you. All right, the way a traffic controller works, we have to have a ring structure. The ring structure describes the operation on how the controller works. The phase sequence that we go. We go to the main street, to the ped, side street left turns, side street, main street left turns, and around we go. Right? Our M60 controllers, all controllers that are out today, are made up of 4 rings. They're called a 4-ring machine. We can do 16 phases. Okay? Let me add this in there a little bit. So somewhere. All right. So if each controller has 4 rings and 16 phases, right? Your older controllers that we had, like I talked about, M10s, M11s. I used to work at a peak dealer, so we had L&D 8000s. Those were 2-ring machines, right? They only did 8 phases, okay? With everything that we going on, when we get into traffic cabinets, you'll see a lot of cabinets come out. They were always 12-position cabinets. Now there's 16-position cabinets because we do flash and yellow arrow. We're starting to do more concurrent ped phases. So we need all these available load switch positions to do what we got to do. I'm going to describe a basic single ring and dual ring sequence of operation. Okay. So up here, you'll see we have ring 1, and this is described as phase 1, 2, 3, and 4, and ring 2, 5, 6, 7, and 8. That's our default. Okay. That's the defaults in the controller. If you get into anything advanced or specific sequences, I can manipulate this ring structure to do whatever I want. This is what you're going to use like 95% of the time. All right. And the key word here is ring. So it has to become circular. And when we get into the ring structure, that'll make a little more sense. So we go 1, 2, 3, 4, and then back to 1, 5, 6, 7, 8, back to 5. Right. And then we have something called a barrier here, which basically everything on here has to cross the barrier at the same time to get to the other side. All right? If we're running a single ring sequence, so basically we're generally only using 1, 2, 3, and 4. Okay. We're going 1, 2, 3, 4. This is the standard intersection that you would see, right? You typically would have an advanced left turn. Here's your main street. Here's your side street. You would have an advanced left turn going here, which we would call phase 1. And we'd also have the through, which would be an overlap, a 1 + 2. Okay. On the southbound side, we'll have a phase 2. When we go to the side street, we'll have a phase 3 left turn. We'll have another overlap, which is a 3 + 4, which will come up with the other opposing. Right? So the way it would work traditionally, phase 1 comes on, the overlap comes on. So we'll say this is northbound. So we have a direction going. Right? For those of you, it's on north symbol. Right? So it comes on, we get the advanced left turn, we get the through movement, 1 and the 1 + 2. Right? So right here, we're in this part of the ring. The phase 1 left turn times out. So once this clears, now we can bring up phase 2. So because the overlap is 1 + 2, we have both main street movements on. So we've gone from 1 to 2. All right? In this situation, once 2 clears out, they both clear out, we now go to 3. So we've left 2 and we've gone to 3. 3 is your left turn on your side street traveling westbound if we're looking at our directional. With the overlap, we bring up the through movement. Once phase 3 left turn clears out, this stays on, and we bring in our eastbound 4. So now we've gone from 3 to 4. So we've gone from 1 to 2 to 3 to 4. 1 to 2 to 3 to 4. Right? It's just a circular ring. When 4 clears, we go all the way back to 1, and the process starts all over again. Very simple, very basic. That's the most common sequence that we see out there on the road. Basically, the only downside to this, and this is the way a lot of your older intersections are wired, is the way they're wired in the field is they tie a lot of these phasings in together. So a lot of times you won't even, they'll just make this both phase 3 or both phase 4. So all these signal wires are tied together in the field. So when you come in to do preemption, you'll hear the term, the field wiring has to be split because the preemption wants to do just this one or just this one. So if I get rid of this, and make that all a 4, that would be another way that you look at it. So you may have 1, 2, and then you could say 3 is like your exclusive ped. Right? That'd be the other comment if you had peds out there. So the advanced 1, the 1 plus 2, the 2, the 3 ped comes on, all the traffic stops, so we can see our ped come on, and then phase 4, disregard this overlap, I'm just not erasing it, and then all 4s would come on. But again, we go 1, 2, 3, 4, 1, 2, 3, 4. So that's our most basic sequence. 1, 2, 3, and 4. 1's your advanced, 2's your through, 3 is your ped, 4 is your side street. We see this everywhere out. In all of New England, this is a very common intersection. I'll just put that back. All right. No questions, right, Wayne? Okay, so far so good. All right, next. We're going to go to a dual ring sequence. Dual ring, we go to a dual ring because it gives us more flexibility. It allows us to separate phasing for detection, for preemption, for coordination. This was more commonly used, especially because in older intersections, you'll go to some cabinets, they only have 4 load switch positions or 8 load switch positions. So basically, we just didn't break out a lot of this. Now with our 12 position and 16 positions, it makes the most sense to kind of do it this way. There'll be applications, if you're running 2 intersections together, sometimes we'll just run that as a sequential, 1, 2, 3, 4, 5, 6, 7, 8, 9. And we'll just use a lot of overlaps. When we go to a dual ring, we kind of get rid of those overlaps because everything becomes its own individual phase. So if you look over here, oh, I see where I messed up. Hold on. That would have made more sense. So that's your sequential 1, 2, 3, 4. 1, 2, 3, 4, 1, 2, 3, 4. All right. Now we go to our dual ring. Okay. So now we have the same thing. 1, 2, 3, 4. Now we're going to incorporate our 5, 6, 7, 8 in the bottom. And the one thing you'll notice is I've added a phase 9. Phase 9 now is typically our exclusive ped. Your exclusive ped movement, when all the peds come on together, all the traffic has a red. And typically that follows the main street, okay? That way we know Main Street traffic is the busiest movement. We get that to a complete stop, and then they found that that's the safest period to bring up the peds because you stop the majority of the traffic, side street isn't moving, we move the peds, and then we go around, there's no left turns, they're all waiting for everything to go. So now we've replaced, if you notice, we replace our overlaps with straight phasing. So our left turns all become our odd phases. Our through movements become our even phases. We work with a large number of consultants. This is the standard ring structure that a lot of them follow. Sometimes you'll get a consultant, maybe they don't do a lot of traffic, they do wastewater or whatever. They'll come in and they tend to reverse these phases. They'll make it go 1, 2, 3, 4, 5, 6, 7, 8. We try to educate those guys. Let's stay consistent because everybody understands how this works. Again, it's a phase designation. We can kind of make it do whatever they want. It's just confusing for folks to come look at it when it's out of sync like this. So if you look at it now, instead of having an overlap over here, I have straight phases. So 1 is my left turn here, 6 is my through, 5 is my left turn, 2 is my through, 3 is my left turn, 8 is my through, 7 is my left turn, 4 is my through, 9 is my exclusive pet. All right? The way that works with the ring structure, because you guys are all used to seeing it like this, the left turns can come on together, 1 and 5. I can have a left turn and a through come on, 2 and 5. Left turn 1 and 6, right? We know that compatibility. And then our side streets, same thing. We can have 3 and 7 come on together. We can have 3 and 8 come up if there's no call on 7. Or 4 and 7 come on if there's no call on 3. And then 4 and 8. So that's the compatibility the way we see it in the street. The way it translates to the controller, it looks something like this. 1 and 5 can be on together. 1 and 6 can be on together, right? And then 2 and 5 can be on together. And 2 and 6 can be on together. So the only combination that doesn't work is 1 and 2 and 5 and 6. Because obviously if 1 comes on and 2 comes on, we have a collision. If 5 comes on and 6 comes on, we have a collision. So these are not compatible over here. So it goes down and down, down and down. We don't go left to right. That's a little rule of thumb. Now again, we have these things called barriers. 2 and 6 ends up being on Main Street. 2 and 6 have to clear together. Meaning they go yellow together, they go red together, and then they both transition over to 9. I can't have 2 try to cross without 6. I'll go into a cycle fail, I'll go into a fault. A lot of times you'll have that happen during coordination. If we don't have our timing lined up, that's when you'll try to see that. Or if our ring structures are a little out of sort. When we start introducing like a third ring, we can get things to jump a barrier and we'll get a barrier fail. So now we go, and now 9 comes on by itself. There's nothing down here. And here's our 9 movement. So 9 is compatible with nothing. And when I say compatible, that translates to compatibility in our conflict monitors or our MMUs. You pull out those green cards and you have all those little jumpers in there. So when you look at the jumper card, you'll see 1 and 5, 1 and 6 has a little metal jumper, 2 and 5, 2 and 6 has a little metal jumper. That's saying that those phases are compatible and allowed to be on together. Okay? We clear out of 9, we go through our walk and our clearance, and now we're going to start with 3 and 7. Okay, here's our left turn, here's our left turn. Right? Same thing over here. Here's our 3 and 7, they can be on. 3 and 8 can be on. 4 and 7, 4 and 8. So again, we can go down and diagonal, down and diagonal. We can't go side to side. 3 and 7 comes on. 3 and 8, no 7. 4 and 7, no 3. Or 4 and 8. And if you look at the ring over here, you'll see this. If you look at any of the engineering plans, they'll typically have this little layout where you'll see this structure right here. And then you'll see it go 1 and 5, 2 and 6, 9, 3 and 7, 4 and 8. That's basically the ring structure, the sequence of, it'll be under something called sequence of operation. And that's how they want the intersection to run. So how this operates translates over to this, and that's what we have to put in the controller. So when we go to build the ring structure, this is what we're basing it off of. Okay? So I know some of this was probably new to a lot of you guys. I do this in all the classes. This is basically covered in every sequence class that people do. It's the template that everybody goes by. A lot of you it's review, but hopefully if you have any questions, it still kind of answers some of the questions. If everybody understands that, again, our phasing, our rings, our ring structure, exclusive ped, sequential, dual ring. That covered a lot of terms in the glossary. So it's key that you understand those or make notes of those, because now we're going to go into the phase menu and you're going to hear a lot of these terms again. All right, good? No questions, Wayne? All right. No questions. Hopefully it's because you guys all know. All right. For some of you, I know like Jimmy just texted in, he doesn't have a text box. I know you're doing it on the phone. I'm not sure if that's factored into the equation. And that's probably why the screen doesn't look right to you. I am toggling back and forth, but the screens, like I said, I have two people in here watching it, so the screen looks the way it's supposed to look. So I think Jimmy is just the way you're doing it on the phone. If some of you have a question and you can't get through a text box, go ahead and send me a text and I'll try to answer it that way. That'll kind of be the workaround till we get through this, but some people are texting in, are able to text. They just said hello, whatever. All right. You're welcome, Jimmy. Always happy to help you out. All right. So now we're going to go into some of the phase data. This is where we're going to start plugging in timing and turning phases on and off. Get a drink here. All right. So if you default a controller, if you default a controller and you're in a TS1 cabinet, I can essentially get that controller running by just changing a few parameters in this menu, in this phase menu part right here. I basically just need to manipulate some times and turn phases on and off. And if there is an overlap, it'll run, it just won't run with the overlap. But essentially I can get the controller going just from the screen, assuming that you've defaulted the data. So that's the key about defaulting data. If we're in a TS2 environment, we got to do channel assignments and things like that, so there's a little bit more to it. So that's why it's key to do that. So this is now going to look a little bit different from what you're used to with old M40s and whatnot. It's the same amount of information. We just broke it out into a few more screens to give it a little more flexibility. So if you go to into vehicle times, you'll see vehicle times, dynamic max, recalls, bike, and actuated walk times. If you remember, you'll see 5 is non-lock and miscellaneous. I believe that used to be recalls, so you put the recalls in over there, and then 6 was non-lock, so we've just kind of combined a couple of things together. So it's basically like keeping everything in one little area for you. All right. So here's our basic timing program that we have. Again, all these terms are on this. Min green. Min green is the green time every phase has to time. So right now, again, this is all default programming. I think I just changed the 5s out. If everybody has 5 seconds of min green, that means everybody will go for at least 5 seconds of min green with no vehicle demand. It'll leave and it'll go to the next phase. Bear with me 1 second. So minimum green is the amount of green time that every phase has to service. If you go down to max 1 and max 2, this is where our detection comes in. So when you have working detection, here's our detection boxes. Oh, so you'll see our detection boxes here. I'll time my min green for 2 and 6. And if I have a lot of demand out there hitting those boxes, then I'll start timing the max 1 green. So I'll do a minimum of 5 up to a maximum of 35. If I don't get, once vehicle traffic starts dropping down, if I don't see a vehicle hit this little detection zone within 5 seconds, because my passage timer will start timing down, then the phase is going to gap out. If I have demand the whole time, all the way 35 seconds, then we'll do something called max out. That means it used the maximum amount of green time. So I got my min green time, my passage time, my max green time, and then what we'll commonly use is max 2 time. And what we'll do is use max 2 time during the AM rush and the PM rush. So you'll see a controller say, all right, from 7 to 9 in the morning, I want to push my greens from 35 to 50 seconds, but only from 7 to 9 for that big rush of people in the AM, and then go back down to 35-second maxes until the afternoon where we'll ramp it up again to max 2. The Siemens controller has 6 max times in it now. And this is something I'll get into. We use something called banks, phase banks. So I'll cover the phase banks in a little bit. And then we have our standard yellow time. So when you see something that says /10, that means 1/10 of a second. So our passage time, our yellow time, and our red time, that's 4 seconds. So picture 4.0. Because a lot of times with the formulas for yellow clearance and red clearance, the engineers do, it comes out to 4.5 seconds, 2 seconds of red. It's a formula that they do. So we have to do that into decibels, and that goes up as far as 25 seconds. One thing that I should have mentioned, on the front of the M60s, we have a great button over there. It's a yellow button. It says help. If you ever have a question about what anything means, you hit that help button, and basically it's like a virtual manual that comes out. And these are all the terms and everything that basically come right out of the manual and help you explain what every interval data is. And this is throughout, no matter where I go, as I move it around, you'll see that the help screen changes. So I go to yellow, so I go to the max 2 in green, I go to max 1. So that's kind of a neat, that's one of the major highlights of an M60 in the Linux is we now have this this virtual type help screen that just kind of explains everybody and gives them a definition in case you forget what things are used for. And then you just hit the help again, and it goes back to the lower screen. So those are all our general times that we have. Min green, passage, max 1, 2. Again, if we default a controller, we can run it with the default times. They'll be a little longer. I think the min green times are like 10 and 15. That's a lot longer than what we typically use. Where we typically have if we have working detection, 5 seconds is fine because the detection now controls how long it'll stay in green as a minimum. A lot of times, so when you have a broken loop or your detection fails, basically we now have a constant call. So if utility company comes in and goes and does a saw cut right there, I lose both of these loops. So that means phases 2 and 5 essentially go into recall. So whatever my max green time I'm running, it's going to max that out. So in this scenario, I got phases 2 and 5. So 2 is always going to run 35 seconds, and 5 is always going to run 25 seconds because my loops are broken, and till I get that fixed. One of the questions, is there a help feature when 358D is on an M50? The help feature is there. You just don't have the big help button. You have another little button, but you get a lot of the same help stuff in an M50. So yes, Alex, it is in there. So that's what happens when we lose our detection. When you cut loops, video detection goes down. Now instead of timing the 5-second min green time, we're going to time the max 1 time. And then if we're running the max 2 program, now we run that green time. So that's why it's critical to keep our detection working all the time. If you do run into situations where your detection has failed, you may want to go in and lower some of these times. You could do time of day. So now basically you're running max 2 time of days. So in the off peak, maybe you're running everything down at like 12 seconds or 15 seconds when traffic is really low, and then only running it up to 25 when it's busy. So we're kind of using the max 1 and max 2 until that detection gets repaired. I know at the municipal level, it's super hard to kind of keep loops going. A lot of municipalities have changed over to video detection just because it's tough to keep track of utility companies. They constantly cut up our roadways. It's so painful when new intersections go in 3 months. You see saw cuts and new pavement everywhere, patches, and we lose our detection. The detection is the most critical part of an intersection. We say it all the time. Intersections only run as good as the detection does. Okay, so that's your basic phase timing right there. Here's a feature called Dynamic Max, and we want to encourage people to start using this more. It's basically a generic form of an adaptive system. What an adaptive system does is you have all this technology, infrastructure, software, detection running in an intersection. When the traffic ramps up, the algorithm in an adaptive system basically changes your green time. So it says, okay, instead of having a 25-second green time, I'm going to have a 60-second green time to try to handle all the traffic that goes through. You have to pay a lot, tens of thousands of dollars to get this technology. It works great. I'm not knocking it, but we all don't have the budgets to do it. One feature that doesn't get used enough is called a Dynamic Max. And the way it works is if we go back and let's say I'll make all my max 1 times 10 seconds, okay? So I can't go any higher than 10 seconds. I'll go into my dynamic max, and I'll make those all 30 seconds. Okay? So what happens now is I have a 10-second max green on all my phases. For certain times of the day, I want to run a dynamic max. And what this does is it says, okay, my dynamic max is going to go up to as high as 30 seconds. But the way it works is the second line you'll see right here, it's called a step time, dynamic max step time in tenths of seconds. This value will be either added to or subtracted from the running max time. So what this says is with working detection, when we max out a phase twice, so phase 2 and 6 time 10 seconds 2 times in a row, the next time around we add 5 seconds. So now the max time becomes 15 seconds. If it maxes out 2 times in a row again, now it goes up to 20 seconds. And it'll keep going up 5 seconds at a time to a max of 30. When traffic gets lighter, and what we call gap out, so not using the whole 30 seconds in this case, now my max time will decrease back down to 25 seconds. And this just continually happens throughout the day or whenever you have it turned on because of the dynamic max feature. So it's essentially, it's like a poor man's adaptive that is allowing you fluctuation with your green time. And it's a very simple feature. Controllers, we've had dynamic max in versions of controllers going back 10, 15 years. And nobody uses it. We try to use it in situations that we think are pretty good. But we encourage people to try it when you just can't seem to find a max that works. Try a dynamic max. You got nothing to lose. And you'll see it go up and down based on the traffic. And I think you'll find some pretty good results. And it's super easy to put in. Okay, now we're going to go to recalls. So basically here's a screen. People get a little bit confused with recalls. The default is no recalls. So typically, we'll have 2 and 6. We got 2 and 6 here as on Main Street. So a lot of times you'll see plans come out and they'll say 2 and 6 will be in soft recall. Engineers love to put everything in soft recall. Soft recall is great if all your detection is working. Once your detection starts to break down, soft recall becomes problematic because all soft recall does is hold a call into whatever phase, in this case the Main Street, when there's nobody else around. So when you drive around at 1 in the morning, which I know half the people on, probably most of the people on here, I think Orlando's on here, he spends most of his time driving around at 2 or 3 in the morning. Basically, when you go to a Main Street, it should be resting in green. It's going to rest in green because we have it in soft recall. If we want to rest in the side streets, 4 and 8, we'll put those in soft recall, right? That's not a problem. As soon as the detection breaks down, so in this case, I'll put min recall on 5, right? Let me go back. Take this up. Okay. So if you look at the screen that I have right there, I'm in 2 and 6, right? I'm going to go to 4 because I already had the call in there. And then the call drops away. So if you look on the second line that says VEH, that's vehicle calls. You'll see 2 S's pop up. Okay? Basically, that's just telling me we're in soft recall. So assume it's 2 in the morning, Orlando's cruising down wherever he hangs out, down in New Bedford on Cogswell Ave. He's going down there, he's got the munchies, he wants to get some Cheetos. He's cruising through all the signals, they're all on soft recall, the detection's working, he's going to be back home in 10 minutes. Actually, he's going to be back home in 2 minutes. Then he comes to an intersection that has a broken loop. Boom. What happens now is we're going to keep servicing the side street for no reason. And it's just going to keep sitting there waiting for something to do. And technically, I must have something else programmed in there because that should technically be resting on 4. So actually, I'm impressed that it's keep going like that. Typically, when you have soft recall on and you have a min recall on, it's going to sit there and override the soft recalls. So if you look at the little R's in the vehicles, now we can recall. Now you're seeing it ping-ponging back and forth. Let me look at that soft recall thing and get back to you on that. Because typically soft recall is just a placeholder. It's just a way to keep, a way to keep the intersection resting somewhere when there's no other calls around. That brings us into min recall, right? When we're in min recall, now we're going to service all the phases that are in min recall, regardless of the demand of detection there. But if you notice to the left where it's timing down, it's only timing the minimum time. So you'll see it go min green, and then it's going to drop right out. Let me go back to, and then if we want to go to max recall, now you'll see down there where it's timing out longer time, you'll see where it say max 1. So in min recall, we're going to time on minimum green, and max recall, we're going to time on maximum green. So those are basically, so when you go to put intersections on recall, a lot of times when they turn intersections on for the first time, they'll put the whole thing on max recall because they'd rather service too many cars than not enough cars. And then once you get all the detection up and running, a lot of times Main Street will get left on min recall. So that way, if you have any issues anywhere else, we're always going to service back to the Main Street because we always want to go back to Main Street. So if I go ahead and take my call off of phase 4, that should drop my calls out of 4. And eventually I'm just going to sit and rest in 2 and 6. All right. The other thing that we're getting into now is we have bike recalls because we have bike lanes. So you'll see it now where it's just sitting there in green rest in max out. The problem with that also is when you're in max recall is, like I said, you got to wait that whole maximum green time. So one car comes out, we got to wait for that whole maximum time. In coordination, especially on side streets, when our side street detection gets screwed up over here, right, that becomes a problem when we break our side street loops or we break our left turn loops. That's when we start having, that's when you start getting all the calls that everybody has to wait when there's no cars around. So whether it be from a loop, a zone, infrared, whatever, thermal, whatever you're using for your means of detection, this is when it becomes problematic. Like I said, max recall is fine. You just have to be careful with how you adjust that maximum green, because whatever time you put in there, it's going to time that the whole time. Again, with bikes, we have bike recalls. So in Brookline and in Boston, we're starting to have bike lanes. They actually have bike signals. They have bike detection. They have bike phase timing. So it's just another added thing that, another form of detection that we're going to start using more. And then one other thing that we don't use too much, you'll see number 1, it's called one call. This is basically just a test form. If you just want to input one test call. So all that's going to do is just put in a call once, and then it'll drop out. So typically we'll use that with PEDs. If I got to put in like a quick PED call, I could do the same thing where I'll just put in one PED call. Recall vehicle delay or recall delay in seconds. I can honestly say I've never used this. It's just a delay feature that can be used with recall. I don't know an application that you would use it. Again, there's a lot of functionality in the controller because it's used all over the country, all over the world. So this could be a function that they use out west or internationally or whatever, but recall delays we commonly don't use here. And again, here's again, we get into, here's bike lane green time in seconds. So this is where we can put bike green times in, bike passage times, green delay, yellow delay. There's a lot going on with bikes, as you guys know, bike detection, bike phasing. So we have all this technology and all these programming options that are in the controller. We don't commonly use them, but they are in there. And I know you guys have bike lanes all through your municipalities. Right now, they're just painted green and probably don't do too much. But those bike people have a lot of power and a lot of authority. So the technology's there if we ever have to use it. We just don't really use it that much right now. All right, so that basically covers the vehicle data part of it. Again, I'm not seeing many questions. Here's a section called density times. This is something that really a handful of consultants used to like to do. It's called volume density. Again, just another way to manipulate traffic and how traffic efficiently goes through intersections, and we get certain phases to gap out together or not gap out together. I'm not really going to go through it. It doesn't get used that much. Something where I like to use the dynamic max. Overusing this, a lot of people really don't understand how to use it. Probably why it doesn't get used that much. Pedestrian time. All right. Again, it's going to look a little different than traditionally. We just had one screen that had pedestrian times in it, and they just kind of broke it out a little bit more for us. So you'll see our phasing. One thing I didn't show you on the vehicles, but I'll show you on the PED. If you notice on the screen, you'll see our 1 through 8. There's our phases, right? But we also have 9 through 16. And the way to get to it is, the easiest way is from the top left. If you start scrolling, you'll see our 9 through 16 phases along the top. This is important in pedestrian phasing because typically we use channel 9 or phase 9 to be our PED. Oop. Use the enter sign, Gary. And the one thing you'll notice, I was actually being generous there, is the problem that we have with exclusive PED is this right here. Fine, and enter. So if you look at the exclusive PED timing right there, if I go back to concurrent PED timing, you'll notice it's all 7 seconds. The default is 7 seconds of walk, 8 seconds of PED clear, right? The walk we can kind of be creative with, whatever we want to have it out. We can make that adjust to how many pedestrians we think are crossing the street at one time in their little queue. Yes, sir.
Did you see the question come in? I don't know if you got a text, but what is the difference between soft recall and min recall?
All right, I just had a question come in, so let me go back. All right. So just again to go over min and max recall. I mean, min recall and soft recall. Soft recall, like think of soft recall as just a placeholder. So if you don't have, this is for late at night. So basically we use soft recall because we want to rest in a main street green. So late at night, when nothing's going on your main street, in this case it'd be 2 and 6. We'll put these guys in soft recall. All right. So 2 and 6. So late at night, when I have no other demand around, I'm going to sit in green. So as traffic comes up, as soon as somebody pulls up on the side street, boom, we're going to go right to the side street and service it. When there's no other calls, I'm going to go back to that soft recall. If one of my loops breaks while I'm in soft recall, now I'm going to end up resting in the side street over here, because this ends up becoming a broken loop is similar to a min recall or a max recall, what we refer to as a hard recall. All right. If I have these guys in min, a min recall is a hard recall. And what'll happen is even with this broken loop, I'm going to go back and forth, 2 and 6 and side street, 2 and 6 and side street, because I'm in the min recall. So it's looking at it basically as the same thing. I'm creating a min recall over here because I have a broken loop, but I'm in a min recall over here because I'm programmed to be in over there. So a lot of times that's why people like to put the main street in a min recall. In the event for detection to break down, then they're going to be able to kind of cycle the intersection still, as opposed to having it sit still on a side street or a left turn. And again, that min recall is going to time your minimum time over here, your max one time. I'm sorry, your min time. Sorry about that. So your min recall is going to time whatever your min green time is. Your max recall is going to time whatever your max green time is.
The side street would go to max 1 if you're in free.
I'm in free all the time.
If your loop was broke.
Right. So. Hopefully that answered your question. Who asked that question?
Eric Envy.
Oh, okay. Eric, hopefully that answered your question. Where were we? Now we're in the PEDs. So we go back to, so we were talking about our ped timing. So if you notice, the way we have the ped timing set up here, phases 1 through 8, which are basically going to be your concurrent peds. Concurrent peds are peds that run with vehicles. So basically, I have a phase 8 here. This would be an 8 ped right here. So when this comes on, this 8 comes on. So typically these peds can be a little, the way we figure a ped clearance time is the distance from here to here with a formula. Basically it's 3.5 feet per second per the distance or whatever that is, 4 lanes, 50 feet or something, divided by that, 3.5 into 50, we come up with a value, and that's what our ped clearance time is. So with a concurrent ped, it's not too bad because it's running with vehicle demand all the time. Where we get a little jammed up is when we go to an exclusive ped. So the exclusive ped, the ped clearance time has to be of the longest leg of the intersection. So what happens is a lot of time we know our side streets might only be 2 lanes, where our main street can be 4 lanes with a medium and breakdown lanes. So essentially a person can be crossing from here to here, which would normally only be 15 seconds of clearance. But because it's an exclusive ped, he's going to take up 30 seconds because it's all tied in together. And exclusive peds are very problematic when you're doing a coordinated arterial, because that takes a big chunk of time out of our Main Street coordinated time. And we'll get into that in the coordination section of the program. But just to let you know, that's where you put in. So if you just toggle left and right, I can manipulate the phases 1 through 8, 9 through 16. And down here, we don't use a lot, but walk to, ped clear to. We were talking about this morning. We have a couple of agencies that want to start using it. I'm pretty sure it's more commonly used with APS buttons. So there's a feature in an APS button. Those are your audible pedestrian signals, the ones that make the sounds and vibrate and the beaconing tones. That there's a function you could turn on for the blind folks. If they press and hold it, they'll get an extended walk. So if they hit it once, it'll time the walk 1, ped clear 1, which could be 7 and 8. So let's say we're outside of, because obviously they're for sighted people as well, but you have senior citizens who may need longer time to cross the street. If they turn on this extended ped clearance function and they hold the button in for more than, I believe it's like 1 or 2 seconds, and that's settable. I know it's settable on an APS button. If they hold it in longer, now the controller is going to time the 7 and 15 as opposed to 7 and 8. So again, it's not a function. I know they use it in other parts of the country. We don't commonly use it around here. I expect us to maybe start using it a little bit more because we have APS buttons everywhere. But it is a simple feature that we can put it on. Again, in those intersections where blind folks, elderly folks, maybe around a daycare where you have moms crossing with babies in carriages, you want to get more time, we have that walk clear. Because we don't use it that much, I imagine that that's probably going to, in a coordinated cycle, if you have to account for that, it's probably going to throw you out of coordination and you'll have to go back into it because you're probably not going to want to have to account for that time. So just little things to kind of keep in mind. Again, we have recalls. So typically, basically, you have ped recalls. This is where I like to use the 1 call as a test. In case I'm out there by myself. Yeah.
Where do you add an all red time for an exclusive ped with a solid hand display?
Say it again. Will you add I have a question right now. Say it again, Wayne.
Where do you add an all red time for an exclusive ped with a solid hand display?
Okay, so one thing that's also changed now, you see a lot on it with exclusive peds, is they want something called a you'll see, which is a pretty good idea, is something called an all red buffer. So if I go in and I put my 7 seconds of walk and my 30 seconds of ped clear, when I come out of the ped clear, I'm going to be in an all red. And what you're seeing now, probably started like 4 or 5 years ago, is they want to have an all red buffer period time. So they wanted to, typically we came out of an exclusive ped for like a second and then went right into side street traffic. Now they want to control that green time. So we go put that back in the vehicle times. So because it's a phase 9, we would go right in and put it in our phase 9 red time. So if you wanted, typically you'll see like a 3-second all red buffer. That's where I would put it in for my exclusive ped. If it's a concurrent ped, it's going to run whatever I have in the vehicle time anyway. It's going to run my vehicle yellow and red. But if I have an exclusive, it's going to put it. That's where we're going to do the all red time is, if that makes sense. And then the feature that I'll cover next is we can time the yellow. So what happens now is we time the walk and then we time the don't walk. So if we don't do any of the settings, we'll time the walk, the don't walk, and then the yellow time, and then the red time. So essentially you could have a 6 seconds all buffer, because once the don't walk times down, no vehicle traffic moves. So if I don't do a setting that I'm going to talk about here, I'll actually time the 3 seconds of yellow and the 3 seconds of red. So you have a 6 second buffer, which probably is too long. So I have settings that I'll show you where I can basically say flash the don't walk and the yellow clearance together. So the last 3 seconds, in this case, because I have 3 seconds of yellow, of the clearance will actually time with seconds 12, with 13, 14, and 15, or it's 30, I'm sorry, it's 30 seconds. So 27, 28, 29, and 30 of the clearance will actually time concurrently with the yellow, and then we'll just have the 3 seconds of red. So if I go back, I know that probably sounded a little, so here. So you'll see extended ped clearance. So if you look at it, you can have no ped clearance during green only. That basically means that you're going to time everything. Ped clearance through red clear, ped clearance through yellow change, and then 3 seconds ped clear all buffer. That's that 3 seconds all buffer. So most commonly that we use is the 2. And in this case, because we're a 9, we're going to put it over there in the 9. So that means that our yellow time is going to time concurrently with our ped clearance, so we don't add the yellow time into it, and then we'll just have the red clearance time, if that makes sense. Basically just finish up with the recall. One thing that they're doing right now, ironically enough, is during the virus, a lot of municipalities have decided that for safety's sake, we're going to put all our intersections on ped recall through the controller. Reason being, if people don't have to touch the button, it's one less way to transfer the COVID-19 germ between each other. So if all the peds are on recall, they're going to come up every single time. You'll see the 8 ped come up, the exclusive ped come up. Nobody has to put a button. It's basically fully actuated. It's not actuated, and it's controlled through the controller. Probably, and going back and forth with conversations with different municipalities, not a bad idea in some busier intersections. I don't necessarily know if it's the best approach for your minor intersections where you don't have a lot of pedestrian traffic. So where you get 1 ped an hour, you're gonna stop the intersection every time for the ped cycle. But that's not for us to decide. It's for the governing body of that municipality. They just ask our opinion and we give them our opinion. I know some municipalities went out and changed them all and then went back and changed some of them back. So probably like that little hybrid approach is probably ideal. And then again, the PED delay and recall, we don't commonly use that. Not a feature that we use. A feature that we do use is become very common. It's called the PED offset. So basically it's a walk offset, or they call it an LPI, a leading PED interval. Basically what that is again, whenever you see that slash, it's in tenths of second. Is we want a 3-second leading PED interval. So if I have a 7-second walk, what's going to happen is we're going to stop that PED 3 seconds early all by itself. So the PED signal is going to come on 3 seconds before the vehicle phase starts. Now keep in mind, that 3 seconds comes out of whatever your walk time is. So if your walk time is 7 seconds, you're going to take 3 seconds out of that 7, and then you'll have 4 seconds left. So it's not 3 seconds plus your 7, it's 3 seconds comes out of your 7. So people get a little confused on that. You can make the whole walk the interval, it's whatever you want to do. But that's very common. If you look at the codes underneath, you can make that an advance or a delay. The default is an advance. That's the most common one that we use. Again, there's applications for a delay. I've never really seen one, but it's the functions in there if you want to use it. So on the plans, on the traffic signal plans, you'll see LPI, and they refer to that as a leading PED interval. And that's where you would see that in there. In the older controllers, this is kind of put in a different place, a little trickier to find. So it's kind of something that they added back in the PED. So when you're doing your PED timer, you kind of do it all in the pedestrian menu. So that one kind of works out a little simply. All right, so that kind of covers our PED. So we're coming up on 11:30, so I figured we would only get through phase menu today, the phase data, so we'll have enough time to kind of finish up the phase menu, the phase data portion of it, and then we'll start with unit data on the next go around. We'll go to phase initialization. So phase initialization basically just says where I turn my phases on and off. So I go back to when I said, if you default a controller, in a TS1 controller, you could essentially come in here, and let's say I'm using this simple ring 1 structure right here, where I'm basically just using 4 phases. And if I went 1, 4, 1, 1, 0, 0, 0, that intersection would pretty much come up and run by itself. And all I had to do was come to this one screen and turn phases on and off. Technically, it would run with all the other phases on. You would just have a lot of red. You would have an all red time because it's going to cycle through all those other phases. So we want to turn off those unused phases. Basically, what this is saying is just 1 is active, 0 is none, 1 is inactive, and then we have to determine a color that we want the main street to come out on. So I could make this, if I went like that, and this is starting to happen in other parts of the country, they're basically they're flashing all red. They're going away from flashing yellow, flashing red, and they're flashing in all red, and they're actually coming out in a red. So if I go like that, I'm sorry, I'm gonna come out in a red, right? We don't usually do it around here. For years and years and years, we initialized in the yellow. So when we came out of flash, we would have yellow on the main street. So we'd have yellow on our main line and red on our side street. So we come out, time 3 seconds of the yellow, the red, and then go right to the side street. Which it was safer they thought it was safer to come out in yellow. The only problem is you went right into the minor phasement, the minor movement. So now most intersections we initialize in green. So if you look at the code below, you'll see where 4 says green. So now when we come out, we can usually bang right out into the main line into green on 2 and 6. And then we'll time our min, and then we'll start cycling around to all the other intersections. The lower section over here, non-actuated response. Basically, phases are actuated or non-actuated. If they're actuated or fully actuated, that means that they have a detection device controlling the demand of them. PEDs are actuated, vehicles are actuated. If they're non-actuated, that means that the controller is taking over that command of how that phases. So typically, we use non-actuation when we're in coordination, so we don't program it here, we program it in the coordination section. So basically, we commonly just zero all these out. So basically, initialization, turn on and off. This is an important screen. We'll go to 5 for non-lock and miscellaneous. So here is where we do, so the default is non-locking memory. So if I have zones over here, so I have a zone over here, and I have that in non-lock memory. What that means is when a vehicle pulls on it, and sometimes you have zones that are set back, or specifically a right turning zone over here. When the vehicle puts on it, he's going to input a call into the controller. So the controller is going to see the vehicle demand, it's going to put the call in. If this guy comes up and decides to take a right turn while I'm in non-lock, the problem is it's going to hold the call. So basically, I've lost all my presence. I've lost my presence detection on the loop because that phase is in non-lock. So ideally what we want to do is we want to put it in, in locking memory. We want to put it in non-locking memory. If it's in locking memory, as soon as the vehicle goes over the loop, it's going to input the call. When the vehicle drives off of the loop, it's going to not drop the call and service that phase anyway. So on right hand turns, that's why a lot of times you'll put delays on right turn detection for 5 seconds or 8 seconds, because you have a lot of vehicles, they pull up, they see if it's safe to go, and they take a right. So we don't want to service that side street for one car if he can take a free right turn. I know it depends on which state you're in, it varies, right turn on red, things of that nature. But if we're in 0, we're in locking memory, okay? If we're in a 1, which is what we're more commonly in if we have working detection, we're in non-locking detection. So the vehicle pulls up, he puts a call in, as soon as he drives off the loop, the call goes away. So basically we're going to put all detection in non-lock, so that way we have what we call refers to the present feature. There's only a call present when there's a vehicle on the zone. Another feature that we use, you'll see it'll call dual entry, or referred to, it's called 2 entry on here, or dual entry. So basically what's that saying is, you'll notice that I put it on the side street calls of 4 and 8. So I got my zones over here. And really what this is they want to keep consistency at the intersection. If a vehicle pulls up on 8, it's automatically going to put a call into 4. So what it's going to do is it's always going to bring up these green signals together, as opposed to just having this green come up by itself and this stay in red. So whenever we use dual entry, it's just that we want to have those concurrent phases come on together. So most commonly it's used on the side street with the left turns, or most commonly with 4 and 8, that you want to bring both of those side streets up together. The last couple of things is last car passage, conditional service, no simultaneous gap out. Again, these are features not used commonly. If I bring out like simultaneous gap out, I want them both to gap out together. I don't want, if I bring those two phases on, those side street phases on together, I want them to both leave together. So it just kind of creates a little bit of consistency between the intersection. Because if I have demand on 8 and I don't have demand on 4, 4 can gap out and 8 can stay on. It's all depend on how on our vehicle demand out there. Special sequence. This is where we do any type of omitting. So this a lot of times would come in our phase 1, in our single ring application. So a lot of times you'll see this left turn come on. So typically the signal up here will be, we'll use a doghouse. right? It's kind of, they look at doghouse, but you get the gist of it. So. So in a doghouse, right, my phase one is just my green arrow and my yellow arrow. That's a little small, I apologize. That's a green arrow and a left and a yellow arrow. So phase one comes on, I have my green arrow come on, then that times out and my yellow arrow comes out. But people can still make a left turn as long as it's safe. That's called a protected permissive movement, right? It was protected with the arrow, and then it becomes permissive based on if there's gaps in the traffic over here. If I have a detection loop here, what we'll do sometimes is, if this is a busier left hand, a busier left turn, what'll happen is, if vehicles continually come up over here, it'll stop this approach and it'll service this green. So basically, it'll just ping pong back here. This stays green all the time, but this will go green, then this will go green, then this will go green. So it gets a little frustrating because it shuts down. This is the Main Street approach. So that can get shut down a lot and they may not want to happen. So in this screen over here, what they can do is say, when phase two is on, when phase two is active, we want to omit phase one. So that way it alleviates this teeter-tottering or ping-ponging back and forth. So we can say when phase two is on, we omit one. And then what happens is, once we leave two and go to a side street, this omit drops, and then we can service it again the next time around. So that's the most common way that I see that the omit is used, is basically just to shut this guy down so we don't keep going back and forth. The minus yellow, I don't know if I've ever really used this before. Minus yellow omits the yellow. And this would be an omitted call. So essentially, if I omit the call, I can make this call another phase if I want to. Again, it's a feature in there. I don't ever recall using it, but it's a feature that's available in there. Probably if you have a specific intersection with a specific application. So that's how we do the omitting. So that's common. So in your smaller intersections with like single lane and these type of left turns over here, we have the ability to omit that. I know in Connecticut it's very common, they like to omit phasings. Here's one of the screens that changed quite a bit. Our detector configuration. So this is where we do all our detector assignments, our pet assignments. One nice feature is if you notice to the right, you'll have this overview B. So overview B brings up our entire, it kind of gives you the overview of what all your channels are. So you'll see at the top, we have vehicle detectors channel 1 through 8, vehicle detectors 9 through 16. So, and this is, again, this is just defaulted. So we have 1, 2, 3, 4, 5, 6, 7, 8. In TS1, that's all it's ever going to be. If we were doing TS2, it would look something like this. Ooh. Get out of here. All right. So I can't change programming from this parameter, but what I do if I want to change it, I hit E, and now it brings up my programming screen where I can make all my changes that I want to, depending on what channel assignment that it has to be. So here it's 2, basically it's just 1s and 0s. If I want to make that a 6, and I hit enter, oops. Now you'll see you go back and now it says 1 and 6. So especially when we're doing like video detection and we want to know what channels are assigned to what, this is a nice screen that we can go to. If I want to go into the regular screen, so you'll see where it says vehicles 1 to 8, 9 to 16. You go to 1 and then it brings up vehicles 1 through 8. So if I go to 1, now it just gets me back to that same screen. And you'll see where I have my vehicle assignment, a switched phase. So again, switch phase would be used if I have zones like this, And maybe I want this zone to call phase 1 when this is in 1, but then when phase 2 comes on, I want it to switch and then call and extend phase 2. So if you have like a dual purpose lane, I can have a dual purpose call different phases depending on where I am in the sequence. And basically I would just go like that. So the assigned phase is 1, and then it'll switch to phase 2. You have a lot of parameters down here. One thing I will tell you is if you ever have detection program and you notice that it's calling and I'm seeing the active status screens come over, make sure that you have these 3 ones in here, call, pass, and added. Because if I zero those out, then it won't input a call. It won't acknowledge the call and place it into the phase. That's like little quirky things. Going back to that 357, we would do the default and this wouldn't come on. So these are little quirky things we've learned over time. Your extension and delay, when I was talking about the right turn. So if I wanted to put a delay over there, so again, /10, that's only 8 seconds, not 80 seconds. So I put an 8-second delay on this right turn, which means a car can sit here for up to 8 seconds before it actually places the call. So ideally this loop would probably be up here. The car pulls up, he wants to make a right turn. So the delay timer starts timing down, 87654. He takes a right, and now it drops out and it doesn't place a call. So that's most commonly where you see the delays on your right turns. Sometimes you'll see them on your left turns over there, but that's where we commonly use our delay timers. And you would just basically keep going through. So 1, 2, 3, 4, 5, 6, 7, 8, and then if you have 9 through 16, you have additional ones. You got to pay attention a little bit here. So you go to 2 for 9 through 16. So technically the keys are 1, 2, 3, 4, 5, 6, 7, 8, but you'll see the vehicle detector say 9, 10, 11, and 12. So when I hit key 3, I'm really bringing up vehicle detector 11. So just kind of pay attention to that. And then obviously we go up to 64 channels of detection. One thing, like, going back to what the folks that are using adaptive signal control, where you're using a lot of these loops. Commonly, we don't use more than like 16, sometimes even less. But when you get into adaptive, you have your presence loop, you have counting loops, you have advanced loops, you have departure loops. So it's easy to eat up 40 or 50 loops, loop channels like it's nothing. So that's why there's so many. And when we go to like ATC, I think it goes out to like 128. So it's just more and more and more. We'll go to the PED detection. So same thing, you'll see where the PEDs are broken down. We go to 1, and we have the same thing. Again, with the PEDs, you'll notice the mode over here. So that's key. 0 is for vehicles, 1s are for PEDs. I can actually use these for any mode that I want, so I could change it to a vehicle if I needed it. Sometimes when we use fire station flashing signals or mid blocks where we don't have any vehicle actuations, every phase has to have a vehicle call programmed for it, or it'll go into a fault. So this is a place where we can make phase 2, we can make phase 1, there's no vehicle demand. We can come in here and I can put the call in here, so I'm not into a constant call or a recall, that I can satisfy it over here. So this is basically just where you would put in all your PED detection. This is where we do overlaps, so we're doing overlapping PEDs. So let's say you got a concurrent, again, you got to use 1s and 0s, they don't take anything else. So a lot of times we'll have a hybrid intersection that'll have a combination of concurrent PEDs and an exclusive PED. So a lot of times you'll have this PED right here will be concurrent. So if I hit this button or this button, in this case I put an 8, but it would come up, just this PED would come up. If I hit this button, the button going this way, then all the PEDs will come up. So this guy can come up by itself or come up as part of the whole exclusive PED movement. So this is where we would put in PED overlaps. This is one way to do PED overlaps. We can also do it through the ring structure, but this is the most common place that we do PED overlaps. Special detectors, again, they're special detectors if we want to find another use for them, if we're using for counting or anything like this. This is where we do special detectors. Again, they come up, same basic programming. Oop, I don't want that. So again, this is where, and then it just goes back to that, that overview screen that you can use. So it's kind of nice. So if you're watching active status down below, you know what channels are being assigned to which detector and where they're being called. So the last thing I'm going to cover is something called phase bank. So if you look down there in the middle of the screen, it'll say denotes bankable data. And a couple of people have run into this already. So basically what they're doing is I can take everything. So I go into phase data. I can basically take vehicle data, PED data, initial, that all falls under the phase bank. And if you look to the right, you'll see a 1 in parentheses. What do we call that?
Brackets.
Brackets. Oh, I didn't realize you had it over there. So the brackets, that denotes bankable data. That means I can put that into a phase bank. I have 4 available phase banks, and I can control those phase banks by time of day. So if I go to 9 to select phase bank, I just hit a 2, then I hit F, you'll notice that denotes bankable data 2. So now I have a whole set of parameters that I could change. If I wanted to change, this is the way that we do additional max 2 timings. So I could have 2 max times in bank 1, 2 and 2, 2 and 3, and I can run these all time of day, giving me 8 max times essentially. The one thing where people get jammed up a little bit, and that's typically how we use them right now, is for max times. Because you'll see plans come out that'll say max 1, max 2, max 3, max 4. The way we do it in a Siemens controller is through the phase banks. We used to kind of have that convoluted way where we had to put times in the vehicle detection, 33 to 48, and that was a little clunky for people. So now we do it this way. The one thing you got to remember is we all run into the situation where we go out, we have a situation where the intersection isn't cycling, we go to put the intersection in recall, and I program it in recall, and my intersection is not cycling in recall, it's sitting still. I bang my head against the cabinet a couple of times, I kind of figure out, and then I realize that I'm programming in phase bank 1, but the controller is running phase bank 2. So now I have to go into phase 2 and put my recalls in phase 2, and then I'll see them go into activation. So the phase banks are very helpful. You just have to be cognizant of them when you're using them. So I can change this to 3. So that's a piece of data when you're doing programming, you want to start taking note of what phase bank that you're running. And I'm just scrolling through the different phase banks that you have. And the other thing you'll be able to tell too is the phase bank in the middle say ring timers AS:00, and it'll say B:111. We're running it by time of day. That's going to tell you what bank that we're running. So that'll say, if it doesn't say 111 and you're programming stuff and it's not changing, look there because we're probably in bank 2 or bank 3. All right, so that's a new feature. It sounds a little hokey, but it's actually very effective once you get comfortable with it. It allows you to change a lot of things. And then you just go into when I show you time of day, basically you just turn it on and off, bank 1, bank 2, through time of day, the way you would like a max time. So it's kind of easy to use. And then basically, if you go into 8, we can copy the banks to wherever. So what we typically do is we'll program phase bank 1, and a lot of times we'll copy it to 2, 3, 4. My recommendation, if you're just changing max 2 times or maximum times, copy the whole bank and then go into bank 2 and just change what you gotta change. So that way you know the program is consistent from 1 to 2 to 3 and just